Welcome to my presentation. My project is comparing econometric deep learning and hybrid models for the S&P 500 volatility forecast. I'm Roland Otinio. My supervisor is Achilles Kufonikos. And my project is category A0, as I only use public financial data and adhere to all university ethical guidelines. So what is my project about? Well, my project is to try and improve the prediction of volatilities for the markets and compared to the industry standard. So what is volatility? Volatility is a measure of market instability. So high volatility normally equals high risk. On the right, you can see the S&P 500 over the last 25 years, and you can see the VIX index over the last 25 years. So the S&P 500, you can see had a big crash in 2008 and during the coronavirus pandemic. And you can see the VIX also shot up during those two periods. So the VIX is known as the fear index, and it spikes during crashes. So my aim is to see if AI models can improve prediction compared to the traditional methods currently being used. So what are the traditional methods? Traditional methods are the econometric methods, which are currently the industry standards. And they use statistical rules to predict future volatility based on past volatility. So some examples of those that I tested were the Arch, Garch, eGarch, GJR Garch, and AppArch. So we've also got AI deep learning models. These work differently. They automatically learn complex hidden patterns directly from data without predefined rules. And I tested the LSTM by itself using with the S&P 500 and the LSTM with the VIX. So based on those, based on the econometric best performing model, which was the AppArch, I fitted it onto the LSTM and onto the VIX LSTM to see if the hybrid models, which are a new approach, which combines both econometric and deep learning methods, hoping to benefit from the strengths of both, if they can improve the model's forecast. So for the hybrid ones, I tested the AppArch LSTM and I tested the AppArch VIX LSTM. So my key findings were that the AppArch, all of the models that were the winners improved from the Arch, but the AppArch improved only at 4.7% compared to the Arch on the unseen test data. The VIX LSTM improved 61.5% compared to the baseline Arch model, and the AppArch VIX LSTM improved 55% compared to the baseline model. So the winner was the VIX LSTM with over 60% improvement on the standard Arch benchmark. The results show that there's a trade-off between complexity and stability, as the more complex AppArch VIX LSTM wasn't as good as the simpler VIX LSTM. And it also shows, on average, the AI-based models, so the ones with deep learning, demonstrated superior robustness and reliability compared to traditional methods. Tools I used were quite simple. So I used the S&P 500 data for the last 25 years, which I downloaded from Yahoo Finance, and I did the same with the VIX, which is the fear index. So I downloaded it from Yahoo Finance from the last 25 years. And with that, with both of them, I used the close price, and I plotted them, and you can see here the plots, which is the same as before. So 1 second, yeah. So you can see the S&P 500 consistently rising over than the 2008 and the 2020 recessions, and you can see the VIX, which really, it does go up and down a lot, but it really shoots up during 2008 and 2020 pandemic as well. So after that, I did the bake-off between all the different models. So I tested the econometric models first. So I did the Arch, the Garch, the eGarch, the GJR Garch, the AppArch models at first, and then I did the deep learning models, which are the standalone LSTM, and then the VIX enhanced LSTM. So going back to the econometric models, I chose the best performing one, which was the AppArch, and with that, I made hybrid models. So I made the AppArch LSTM, and then I made the AppArch VIX LSTM. And then I tested them all, and I put them in this table here, and I'll show you the results. Here's the results. So you can see that the LSTM was the winner, and GJR Garch was the worst one out of all of them. So I evaluated them using the RMSE, which stands for root mean squared error. So effectively, it measures the distance between the volatility that the model calculated versus the actual volatility at the time. So the lower the number, it means that there's a lower distance between the actual volatility and the volatility the model predicted. So it means that that model did better than a model that has a really high number. So you can see that LSTM VIX had 0.1219, etc. And the GJR Garch had 0.98. So there's a big difference between the two. Anyway, next I chose the winners of each category. So for the econometric one, I chose the AppArch. For the deep learning one, I used the LSTM VIX, and for the hybrid one, I used the AppArch VIX LSTM. And I did the same, but this time I tested them on the test data. So this was data that they hadn't seen before, and I was hoping to plot the predictions or forecasts compared to the actual volatility at the time. So you can see I did the arch model here, I did the up arch model, I did the VIX LSTM model, and I did the up arch VIX LSTM model. And before I show you the results, I want to talk about some issues that I had. So the econometric models, such as the arch and the up arch models that I tested, I wanted to use a rolling forecast, which is a more complex, type of forecast, but it's able to give you results that you can plot. But when I did them with those econometric models, they failed because they either didn't converge or they had some parameters which were not statistically significant, meaning that essentially it didn't give you results that you could plot and you could trust. However, with the LSTM and models, they always plotted regardless of the data, whether they're seen or not. So here's the results I got from all of the models I tested. So I will show you the table first. So you can see that the best performing was the VIX LSTM model, which got even better when on unseen data. And this is because at this point, they had a lot more data to be trained on. So before you only had the training data, but at this point, you had the training and the validation data. So next, it was the up arch VIX LSTM, which was just slightly below the simpler VIX LSTM. And then you had the up arch and then the arch. I also tested the arch because I wanted the baseline. So the arch was my baseline. And so you can see here that the arch was the baseline. The up arch improved by 4.7% roughly compared to the arch. The VIX LSTM improved 61.5%, which is massive, and then the up arch VIX LSTM improved by 54.9%, so almost 55%. So the winner was the VIX LSTM with over 60% improvement compared to the arch benchmark, which was slightly confusing for me because I thought the more data you give it, so you give it the up arch data, you give it the VIX, you give it the S&P 500 log returns into the LSTM, I'd expected it to consistently improve and improve data, improve forecast, but it looks like there's a trade-off between complexity and stability. And generally speaking, the AI-based models demonstrate superior robustness and reliability compared to traditional models. As traditional models, often I had to do a lot of hyperparameter tuning to make sure that they worked and to make sure that I could get reliable scores. So in conclusion, I'd say that the VIX LSTM model was the definite winner. It improved once again by 61.5%. Also, a big thing I noticed was that the data quality is more important than the model complexity and the amount of data you give each model. So the VIX is really good quality data, as it really represents how the market feels about the S&P 500 at the current time, compared to the other data of the up arch and S&P 500 log returns as well. So also the AI-based models were more robust than traditional econometric models in different scenarios. So they took less hyperparameter tuning, and also the results were more consistent even when I changed different settings for each model compared to the econometric ones, which really changed up and down depending on how I tune the parameters. But yeah, this was my presentation. Thank you very much for listening. Goodbye.